Hello, good evening my dear students. Today we are going to do the part 2 of Pondicherry University MSc Chemistry previous year paper. I have actually taken some questions from the 2017 paper and some questions from the 2018 paper as well. So check this regularly so that you can complete all the previous year question paper before your examination. So the first question today is hybridization in XeF4. As I said in the previous video, without studying this part, this VSEPR, hybridization and the shape, without studying that, you don't go to the examination because you're definitely going to lose the marks. In the same question paper, more than one question has been asked from hybridization and shape part. So how to do this? I have already said the formula. What is the formula of finding the hybridization? Half into number of valence electrons of the central metal atom V plus number of monovalent atoms plus the charge of anion minus the charge of cation. Here we do not have an anion or a cation. Therefore, we could directly write half into what is the valence electron of xenon? It is 8. And how many monovalent? Fluorine is a monovalent atom, so it is 4. And therefore, we are having the answer 6. And according to our video, corresponding to 6, we should have sp3d2. And do we have that option? Yes, we do. Our option C would be the answer. You can see this. By studying one simple shortcut, you can answer three different kinds of questions actually. That is, if you know how to find the hybridization, you can know the shape and also you can know the bond angle. As simple as that. You get very good marks just by studying this one simple formula. Now we'll go to the second one. Here the second question is the reagent used in Stobbe's condensation. You can see most of the times very complicated reactions are not asked to you, but instead most of the times the question are asked from the reagents for a particular reaction. So you should be very thorough with the common reagents. Now you can see anhydrous AlCl3. This is a Lewis acid, and where we have seen this mostly? We have seen this mostly in the Friedel-Crafts reactions, and also we have seen this in one more place that you might not have studied very well. There is a reaction called Mervin-Pondorf-Verley reaction. The name seems very big. You need not study the reaction, but simply know that there is a name like this and AlCl3 is used for that. Then what is ZnHCl? In which reaction is this one used? This is used in the Clemmensen reaction. Okay, Clemmensen reaction. Then KNH2 in liquid NH3. This is used in the Benzene mechanism. That is our elimination addition reaction. Then finally, so this would be our answer. Stobbe's condensation, that is potassium tertiary butoxide is being used. And what is the reaction? We can simply write the reaction like this. The reaction will be between a ketone and it is specific for the diester of succinic acid. Okay, this is the reagents used for Stobbe's condensation. This is particular for this particular ester. Okay, we need not study the reaction completely. Just know these are the reagents used. Now we will be going to the third question. The third question is the difference between molar heat capacity of gas at constant pressure and constant temperature. What we need to find here, Cp minus Cv is equal to. In my previous video of gaseous state, I have already given Cp minus Cv is equal to R. So R, what is the value of R? Is it in joules? It should be around 8.314, but it is not just joules, it should be joules per Kelvin per mole, but here Kelvin and mole is not given. So the closest option would be option B. Option C, per mole is given, but it is given in kilojoules, which may not be correct because into 10 raised to 3 should be there if it is kilojoules. So our closest option would be option B, 8.314. Our next question is the effective number of metal atom in ferrocene. This is very simple because it is 18. It is 18. That is, what is ferrocene? Ferrocene is having 2 cyclopentadienyl complexes that gives 5 each. and also the central metal atom will be iron. Iron is having 8, therefore it sums up to be 18, and it is extremely important in case of organometallic chemistry, ferrocene. I'll be taking a class on ferrocene, and please do note down all the points for every PG entrance examination. It will be very important. So please do read the part of ferrocene here. So the answer is 18 itself. Now I'll go to the next question. This is very simple question, classically repeated question. What is the condition for spontaneous reaction? What is it? Spontaneous reaction, delta G should be negative. And what is delta G is equal to 0? This is equilibrium. Okay. Equilibrium, delta G should be 0. So that's also done. Now the next question. Next question is the IUPAC name of a heterocyclic compound. What is this compound? This is not pyridine. This is pyrrole. So our option B and option C will not be correct because both those are pyridine. Now we know this group is amino. Now what is the only confusion that exists? The numbering. You should know that we will start numbering from the nitrogen. So 1, 2, 3, 4 and 5, and therefore what will be the answer? 3 amino pyrrole would be the answer, and our option D is the right answer. The next question is the number of unpaired electron present in the HOMO of O2 2+ and O2 minus. I have done video on this part also. This is the molecular orbital theory part, and is very important along with VSEPR theory and shapes. The other very important thing is this one, because the questions can become about bond length, bond order, and electrons and magnetism as well from this question. Variety of question can be asked from this simple question. So if you study that, you can attend a lot of questions. Okay. Now how to write? First of all, we need to know how to write O2. O2 will be written as sigma 1s2. It is having 16 electrons. So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2p Z2. Why is it this so? Because we have already studied. Okay, check that video to know why sigma p to p z is filled before pi. Then it will be pi 2p x2 equal to pi 2p y2, and next it will be 1 each in the pi star 2p x1 equal to pi star 2p y1. Now this is for oxygen. What is the first one asked? For O2 2+. O2 2+ means both these electrons will be going. That is, this will become 0, 0. And is there any unpaired electron now? There are no unpaired electrons. So our answer would be either C or D, because 0 and something else is the answer. The second one asked here is O2 minus. O2 minus means it will be having out of this pi star 2px and pi star 2py, one will be gaining one more electron. Therefore, it results in one unpaired electron. So what will be the answer? It will be option D, 0 and 1. Now the next question. This is all conceptual question, the conversion of units. We can see if nu bar is given in centimeter, how to convert it into meter. What is per centimeter means? It will be 1 by centimeter. Now how to convert 1 by centimeter into 1 by meter? It will be 1 by 10 raised to minus 2 meter. That is equal to 1 by 10 raised to minus 2 per meter, or is equal to 10 raised to 2 per meter. So it should be multiplied by 100 is the answer. Actually, you don't want to do all this multiplication. If you don't want to memorize it by heart, memorize it, then you can do it like this. Otherwise, just simply do it in your mind. You don't need any calculation. I am telling this for the students, those who get confused while they are doing without writing the calculation. Okay. The next question is the skew conformation is an intermediate arrangement between which of the following? It is definitely from the conformation, and it is eclipsed and staggered conformation. Then the final question here is Soret band is an intense dash absorption near the UV region. First of all, you need to know what Soret band is. A Soret band actually is an intense band found in the blue region. Okay, blue region which is found, and it is occurring due to the certain dipole moment shift which results in pi star transition, pi star. So our answer is option C, pi star. And why we are using this Soret band? We are using this to find the absorptions of heme containing moieties. heme containing moieties. So this question maybe can asked in other way, that is we will be asking like this, that is which of the following bands are used to find the absorptions of heme containing moieties, and they can give the names of different bands and along with Soret band, and our answer would be Soret band. So I hope these questions are clear to you. We'll be doing more complex questions in the coming days. These are all to begin with, just to begin with, and to freshen up your concepts. Continue watching our channel for more videos. If you need any theory part, please to ask in the comment section below, else we will be continuing with the previous year question papers only. Thank you so much for watching. Like our channel, subscribe and share to all your friends so that they can also get the practice. Thank you. Have a good day and all the best for you all.